So here it says, draw the image of the following segment after a dilation centered at the origin with a scale factor of 2/3. So what we want to do is take this segment and draw one 2/3 of the length, and it's also 2/3 closer to the origin right here. The way we can do this is just use the coordinates here. So we're going to take the coordinates of these 2 points. So this is at 9, 12, and I know the copy's not that great, but that's at 9, 12, and then this point right here is at 12, 6. And then what we can do is just multiply those coordinates by 2/3. When a dilation is centered at the origin, you can just multiply the coordinates by the scale factor. So we have the first set of coordinates, 9, 12, and we're going to multiply both of those numbers by 2/3. And then 12, 6, multiply both of those numbers by 2/3. And then that'll give us the new coordinates. So in the calculator, there's different ways that you could do this, but just like 9 times 2 divided by 3 will give you 6. And 12 times 2/3 is 8. And so on. 12 times 2/3, 8. 6 times 2/3, or 2/3 times 6 would be 4. And then here are our new coordinates of the new segment. And so we'll graph that. So 6, 8. One, two, three. And then here is our new segment. So this is 2/3 the length of this, if we were to like find the exact length. Also, this point is 2/3 the distance from the origin. So like 2/3, 1/3 here too. Just FYI. So this point is 2/3 from the origin as well. If you need to know that. Okay, and then continuing with the next one, same concept of dilation, just like presented in a slightly different way. So sliding over here. Okay, so over here it says a dilation is centered at the origin with a scale factor of 2, is applied to triangle XYZ. The result is XYZ prime. So XYZ is always the original, and the one with the prime marks is the new one. So then looking at this, it wants us to pull the coordinates off the graph. The original one is at 4, 1, X prime is at 8, 2. And that might be hard to see. I understand it's not a great copy. However, when you have a scale factor of 2, you can just multiply these coordinates by 2. So 5 times 2 would be 10, -4 times 2 would be -8, and you can kind of check to make sure that that looks 10, -8, cool, y prime looks at about there. And then multiply these by 2, -3 times 2 would be -6, -6 times 2, -12, and then here's our new coordinate. And then from here, it wants us to identify like the coordinate rule. So x, y, we're multiplying those coordinates by 2. So 2x, 2y is what we're looking for in the answer choices. So not this, not that. This one looks close, but they put 2y first, which is kind of weird. I saw a lot of you on the benchmark crossing off answers. Good job with that. It's a good test taking practice. One of my high school teachers actually taught it to me, and yeah. Okay, next, over here, same, looking at dilation and scale factor. It says a dilation centered at the origin is applied to figure A. The result is figure B. So it's going from A to B. It's an enlargement. So this would be the original one. And then this is the new. For scale factor, they use K. I don't know why they use K, but it's new over the original. That's how we set it up. Okay, so what we need to do is find a corresponding side and like find the length of that side. So I'd say this corresponds to this, and you could use any one of the sides. I'm just choosing something that I can easily count. So I chose a corresponding side, and I'm going to find the length of that. So this is 2 units. And this is 1, 2, 3, 4, 5, 6 units. And K equals new over the original. 6 divided by 2 is 3. So our scale factor is 3. So this is 3 times the size of this. Yes, Kyla. Good question. So I could use any side. Like I could use this and just count units. It looks like this is 2 units and this is 1, 2, 3, 4, 5, 6. So I could do 6 over 2. Or like the other side, the bottom, it just so happened that that was the same length, but like this bottom here, this to this, those are corresponding. If I counted the units, this is 3 units, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I could do new over the original 9 over 3, and it still comes out to 3. You could do the diagonal too, but I don't want to calculate that length, so it's easiest to choose a side that you can count the units. Good question, Kyla. Okay, and then the last one on the page, we specifically decided to include this one because we've seen stuff like this on the EOC where you have to like set up the ratios and like corresponding parts and stuff like that. So this is good practice for that. Here it's saying there are 3 proportions and you just need to set it up. So AB corresponds to ED right here. So you just from the drop down choose ED or DE, however I put it. It says 1/3, which makes sense because like 4 over 12 would simplify to 1/3. And here it says AC over DF, so AC and DF. AC is 5 and DF is 15. I did try it out. It will accept this fraction not simplified, but if you simplify it, it will equal the 1/3, like divide both, you get 1/3, which is what it should match as. And then you singing? Okay, and then here we go. BC corresponds to EF, so you just choose EF or FE in the drop down here. BC is 6, EF is 18, and then that would simplify to 1/3 if you divide by a common factor, like that. So I did test it out. It will accept like the unsimplified version too. But the real gist of this, or what it's trying to show you, is that it all equals the same proportion, which is what we went over yesterday. And then from this, it seems long, but it's actually pretty simple. It says each pair of side lengths compared is in the same ratio. That is true. This is coincidence. No, it's not coincidence. It's because they're proportional, so cross that out. Each pair of side lengths compared is in the same ratio. True. This is because the side lengths in each pair are lengths of corresponding sides and the triangles are similar. So this would be our correct answer. And the last two say that the side lengths are not in the same ratio, which isn't true. They are in the same ratio, so cross those out. Okay, so I want you to leave this out so I can give you credit for it. And while I go around and give you credit for it, I want you to set up today's notes with like the key idea. So we're kind of switching over here. I want you to write this on the top of 8.2 practice, and then we'll start this in just a second.